So the second talk of this session will be given by Dr. Abdul Ghani Olabi. Dr. Abdul Ghani is a professor and the director of Sustainable Energy and Power System Research Center at the University of Sharjah. He obtained his master and his PhD from Dublin City University. And he's going to talk about digital twin and artificial intelligence for renewable energy and energy storage systems.
Sorry? Oh, pointer, this one. Okay. Okay.
When you're ready, you can start.
Thank you very much. Thank you for your introduction. Thanks for the conference to inviting me. I will talk about digital twin artificial intelligence for renewable energy and energy storage systems. So the application. So only like to introduce myself. I'm directing the center which has 5 group working on renewable energy, energy efficiency, biomass and bioenergy, energy storage system, smart grid and nuclear energy. And we have a lot of outcome as research group. We are looking more to have patent and to have applied project and so on. So only like to start with one thing because the title is about hydrogen fuel cells. So I will talk about our beginning of the innovation of this, what we call it, the beam fuel cell. We invented the flue plate. So we have replaced bipolar flue plate with the foam plate. And we got patent for this work. And we followed by a lot of other activity. Currently, we are working on compressed air energy storage system. And we will see like we have direct application for digital twin and AI. We are working also on development of hydrogen fuel cell, hydrogen production, hydrogen storage, hydrogen transportation. So this is really the current activity. We are working as part of the center, so the group of energy storage system. But in general, we are doing a lot of different things, and we have one patent granted and other applied and so on. So now I will go through my presentation. So I said we will talk about renewable energy and energy storage system, of course, using digital twin and artificial intelligence. We'll start why like renewable energy. So renewable energy mainly, not because we don't have a fuel or it's really the CO2. If you can see how we are suffering from the CO2 increment. So for sure we need to go to renewable energy. And why we need energy storage? Also because you can see when we use solar, wind, whatever, we have big time where we produce a lot of energy. So we need to get this extra and we need to store it to use it on the other normal time. So this is why. Here, like this is summary of the different type of energy storage system. So we have either electrochemical, mechanical, and so on. I will not go through all of them. For sure, you are familiar. So this is here only like if someone can notice there is by mistake missing the fuel cell. So the most important, we miss it in the diagram. But anyway, it summarizes really all the energy storage system. So here, like when we want to talk about digital twin, artificial intelligence, we have to go through the industry 1, 2, 3, 4, but industry 4. Because why? Here, when we start the industrial revolution, so we start to have machine production. We went to industry 2 in the 18th century. So there was machine, electricity, and so on. We went to industry 3. In the 20th century, but now we have industry 4 and we are getting industry 5. So what is industry? What we have in industry 4? We got really this tool, what we are using now. So starting why we ask for digital twin, artificial intelligence, and so on, it's actually, it came from industry and manufacturing. The need, so we need IoT, Internet of Things, we need to get advanced computer, we need to get AI, we need to get digital twin, we need to get cyber physical, we need So all this data, big data and so on, so it came really from Industry 4. So this is really important to mention also about the background of all what we have of advanced technology, digital twin and artificial intelligence. Here, if you can see, it's again summarizing what I said. So here we have, I will go directly to Industry 4. Here, Industry 4, where we have Internet of Things, cyber, IT, and so on. And here, the two questions really. Is it revolution, evolution? So the digital twin with all the different components we are using. So IoT, AI, digital twin. So what you think? So the answer, like, it is really technological evolution and business revolution. If you can look at what we did. So here, revolution because the businesses change. Everything we are doing every day, so change because of what we have, all this technology. Again, Industry 4 and AI and all other things we are talking about. So here, again, in digital twin, we have modularity. So this is the main part. So when we talk about digital twin, we are talking about modularity. We are talking about decentralization. We are talking about virtualization. We are talking about real-time capability. Here in particular, when we go to talk about digital twin. So we are talking about real-time. We are talking in interoperability. We are talking about service orientation. So we'll see some of it now before we go directly to the application of digital twin and artificial intelligence. So here's a different component. I said it came with digital twin, IoT, Internet of Things, so physical object communication with each other and further share information to coordinate decision, iOS, but I will go directly to big data. Big data analytic. Here when we came to the AI. So here enable organization to better gain value from the massive amount of information. Like you mentioned, what is why we have this revolution? Because for two reasons. Yesterday someone mentioned, because we have the data, so we get the big data, and we get technology. If we don't have the big data and technology, we'll never arrive to what we are doing now on AI and on digital twin. So amount of information they are already have and identify what is likely to happen next and what action should be. So I know, like from what I'm doing, I can predict, I can optimize and predict what I'm going to do. Of course, I have the other component. I have cloud computing, augmented and virtual reality. I have additive manufacturing, it's very important. We have simulation and modeling techniques. And here also, I like to emphasize on this simulation and modeling technique because here we are talking the beginning of okay, here we are talking about the digital twin. So design, realization, test, running virtual system, simulate, emulate behavior of physical systems. So here really we are talking directly about digital twin. We have automation and industrial robotic. We have cyber security and so on. So this is really came all from Industry 4. So here we'll go to see what we have in the past. In the past, we have only physical systems. So we do experiment, we get result, we compare with the results. Later on, what recently we have the cyber system. So we built two systems, one digital, one physical, and now currently and future, we are talking about the digital twin. So we get two systems, we get data, data and we can analyze this data and we can feedback and so on. So here really like the advance of Industry 4 leading to digital twin. So here's a history of digital twin starting from 1970. So there was some initial thought about digital twin with NASA and so on. It developed by different professor 1991, more development in 2002, but really the actual digital twin in 2010 by NASA, and here like really officially like we have the digital twin, and it developed more and more by US Air Force. Digital will integrated now in 2023, and we'll see further development coming in this sector. So this is like what is digital twin. Adaptive model emulates the behavior of physical system, getting real-time data. And this is the most important, getting real-time data. So I have the physical system, I have the digital system, and I have the continuous of real-time data, so I can optimize and give feedback to the physical system, so I can even improve the physical system while I am running my digital twin. So we use, of course, in digital twin, we have physical production, behavior data, digital production, time representation system, physical cyber, and so on. So here, what are the 4 questions of digital, leading to digital twin? So the first question, context, where I need to apply digital twin. So here, where I need to apply it, I can apply it for a lot of sector, starting from manufacturing, environment, renewable energy, aerospace, city management, oil and gas, and so on. Of course, here, energy. Second question, when? So when, it means we are talking about the life cycle, beginning of, so here at the beginning we have the design, then we go to the production, service. Okay, so we go directly here. And third question, why? Why? Because this is the customer need. We need to determine, we have to build whatever we are doing. We need to remote monitoring, product design, and so on. And then we come to how to do all these things. So we need to arrive to the digital twin, where we have physical layer, we have computing, and we have network layer, so between the physical and the digital one. So advantage, why we use digital twin? Simulation and optimization, predictive maintenance quality, so I can improve product design, remote monitoring, real-time analysis, and so on. So here I have the physical twin, physical system, I have sensor and control, and this is really the advantage of, and this is really why the technology helped me, because I have more sensor and controllers and so on, and this is led me to this kind of revolution in to get the digital twin. In the other side, the digital twin, we have the algorithm analysis and so on, and of course there is always feedback between both. So here, like, we start from the digital twin, starting from digital model. So to start my digital twin, I need to build my digital model, virtual model developed based on physical model. So whatever I need to define, then I go to machine learning algorithm. I need to go to prediction from what I have here. I have the digital model, I have the machine learning, I have prediction, and then I come to the improvement to improve whatever I am doing. So this will get live feedback, and I can make the improvement. This is example really for digital twin in die casting. So here, like, this is actual model by Dr. Semararo. So here, this is the actual machine, and this is the digital twin. And here, a lot of things made to improve the real model and to give the feedback to improve the real model. So here, like when we talk about renewable energy and energy storage, so here, like digital twin, when we can apply it for wind energy, for solar, for a hydroelectric, geothermal, and also the same for all the different type of energy storage. We will see example in the following slides. So this is also the percentage, for example, wind energy, it has 44% of the total digital twin, and so on for solar, and followed by hydro, geothermal, biomass. This is amount of what we have on publication. So here, for example, digital twin for thermal energy storage. So we will go through different models, but they are almost the same. So we have, this is the modeling. We have sensor thermocouples. We are getting the data. So what data I need to get input? Mostly I will get temperature, some environmental data. So I will have it here from the different sensor I have. I will get the digital model. So here I have the digital model, I have the interface, and then I get the feedback, and I can make any change on the real model. Here, for example, applying for batteries. Yesterday, some of the colleague, he mentioned we saw picture of some explosion for the batteries. So here we can avoid, because here I build the model of the battery. I have all the parameter, everything I need to know about parameter, input parameter, so I can have all the sensor actuator I need, and then I can do my model and so on. And then I can, because there is real data, so I can feed back to the real model, and I can control. If I need to make any maintenance, I need to stop the battery, I need to take it out of the service, and so on and so on. So depend on what I am doing. This is if I have the battery. If I am developing the battery also, I can do something similar. Here again for fuel cell, I can do the same thing. I have the physical layer, I have the digital, I have the connection. So everything I need to look, for example, at flow rate, I need to look at pressure, I need to look even humidity, and so any parameter I like to have it as input, I can look at it, and I can get also the digital model, so it will be very helpful. I can get the feedback also from when I'm using the digital model and give it to the physical model. Again here, the same. Another example of pumped hydro energy. So here also we have pumped hydro. So there is a lot of parameters, like there is, for example, a project in a place called Hatta near Dubai. So they are building 250 megawatts. So if you need to look at anything happen while they are running this pumped hydro energy. So making digital model, so it can give always the feedback. We know exactly when we need to stop, when we need to make maintenance, when we need to make any change in our physical model. Another example, this is for wind turbine, also for solar. So wind turbine, as you know, like if I also make digital model, anything I need from, I'm receiving from the sensor actuator, all the information I need. If I have, for example, strong wind, I need to stop the wind turbine, so it will give me the digital model, will give some feedback to the physical model to tell, let us stop for maintenance, so the digital model will help me to feed the physical model in doing whatever we need to do. So this is like what we think, what we are doing on digital twin. So we have also a lot of things related to artificial intelligence. So here, like starting artificial intelligence, so Artificial intelligence, everyone know all the day we are talking about artificial intelligence. So here technique which enables machine to mimic human behavior. So here we are getting and data calculating and so on. We have machine learning, it's subset of AI, and we have deep learning, which is subset of ML. So here, if we go to, like this is artificial intelligence and artificial intelligence benefits. So here we have natural language processing. So here we have energy consumption analysis. We have regulatory safety compliance. On machine learning, we can have energy forecasting. We have load management, fault, and so on. For robotic, we have also computer vision. So all this element, its function and benefit of artificial intelligence. So here, artificial intelligence also can be helpful in different sectors, making the electric grid smarter and more reliable. We talked today, like someone talked about smart grid. So if I have artificial intelligence, really I control, because the smart grid, the main thing for smart grid really when we have renewable energy. So smart grid, it become very important with the existing or depending on renewable energy. So to make sure like we are really using the renewable energy without problem, without losing the renewable energy we are using, because we have energy. If I don't use it, so I will lose. So if I make this artificial intelligence, so I know exactly what I need, and I can update the grid, optimize demand response, manage the energy or energy management, identify new material, improve computing efficiency, help of optimizing manufacturing process. So all this like benefit, I think most of you went through all this detail in the yesterday and today. So here, this is a general methodology. So here how we start, we get the data collection. I don't want to repeat, already you mentioned, data preparation and so on. So when we get testing the model and so on, and we get the optimization, we get exactly the best model we need to use. Again here, this is like application we're using for PV system. So here again, PV system, I have sensor to give me what I need in the PV system. I need to get the temperature, the degree, like orientation of my grid, and any other parameter related to the environment. So all this information I get, this is the input. I have my N whatever artificial intelligence model, and then I get the output, and I can update, I can get benefit and from this model. I can use it for hydrogen again, hydrogen production. I am producing hydrogen again from solar, from wind, and so on. I can also have what is the input for my hydrogen production. So here I have the different type of hydrogen. So I have all the input, the data, and I can get what is the best output, what is the best hydrogen production, and I can go further to hydrogen storage and hydrogen transportation. So very useful, again, another application. This is again application we are using for compressed air. So compressed air storage system. So we need to compress the air, and then we need to use it. So compressing the air, so we have different input parameters. For example, what is the flow rate, what is the pressure, and so on. Temperature could be also. So later on, direction of the flow. So later on, we can, using the machine learning, we can use artificial intelligence to get what is the best scenario to get the maximum energy from this compressed air storage system. So this is actually like master student did this project. This is overall, so here like kind of summary. If I have energy system, So I have here, of course, like I need the energy resources, I need energy storage. I mean, to get energy storage, I need the renewable energy, I need the internal, all the Wi-Fi, internet model, and so on. Later on, we'll come to this slide. And then we have the data storage, we have the analysis, so we do the the optimization, predictive, smart energy consumption management, and then we go to the feedback and so on. So this is really what I want to talk. I'd like to thank my group here, and in particular, Dr. Semeraro, Professor Muhammad Ali, Professor Abdul, and Engineer Haya for their contribution in this field. Thank you very much.
Thank you very much. Really nice talk.
Thank you.
Do you have any question?
Thank you, Professor. I'm Soumitra, research scientist in Clean Combustion Research Center. So I've worked in industry for some time. My question is, how much of these digital twins are dependent on the physical models that are part of a digital twin?
Okay, no, it's fine. So actually, very good question, because we need the physical model. So if we have the physical model, we need to build the digital model. So exactly like the same. Like you saw the example of, for example, the molding machine. We can do it for anything we are doing, for example, for batteries, for fuel cell. So I build the digital exactly the same like physical. When I get the data, so I can change, I can improve, I can know when I need, for example, to change the battery, I know when I need to make maintenance and so on. So it needs the physical exactly, and then I can create the digital one.
Sorry,
is that a question? Sorry.
It's a physics-based model. Sorry, the physical is your entity, like the hardware.
Yes.
But in the digital model, one uses physics-based models also. For example, if you have to do a chemistry simulation, you will add a chemistry, not just have a digital.
Yeah.
Okay.
So you have the information, all the information on the physical model, whatever chemistry. So you are giving information. So it means data in this case. So the digital model, everything digital can be designed, can be data. You are feeding data to this model. So it's having exactly the same. So the physical is like mirror. And for sometimes they call it the mirror in some of, I have one slide, maybe I didn't go through. They call it the mirror system because exactly the same. But here I don't have it physical. So if there is chemical, I don't have chemical. I have to give the data about the chemical. Okay?
These physical models of different systems are being developed through AI. For example, basically these through AI, you are trying to represent the behavioral physics or performance of different systems. And you try to then improve those estimated behavioral equations of those systems in real time. So my question is maybe because you may not have exact good accurate model at the very first glance, and it keeps on improving. So for some time, there may be certain inaccuracies compared to if you are trying to use the real physical available models for different systems.
So sorry, the question? What is the question exactly?
So, I mean, there are still, in case of if you are trying to use a digital model, there will remain inaccuracies compared to real physical models, real behavioral models of the.
No, when you build the digital, so it's exactly the same. But later on, you are getting you are using, for example, machine learning, you are using algorithm, so you are improving. So this improvement will go to be fed to the physical model. So the digital model will be better than the physical. It will give the information to the physical to act or react, okay?
You mean the physical model that is already available, like the physical working equations, behavioral modeling equations of a system. You are trying to improve those equations, those through these.
Yeah, depend on what we are studying, yes.
Okay.
So for example, If I have like chemical, you mentioned chemical, if I'm looking for battery, so I get the data from the chemical, something like I need to change, the chemical need to be updated, so it will give feedback. Give you other example. For example, if I made digital twin for anaerobic system, so I have the anaerobic system, so the digital twin, I have the same. So because looking at the information, what is the percentage of biogas is generated and so on, what is the force on the blend, like mixer and so on. So later on, they know maybe there is a problem, so they will give feedback to the system, something will happen. Or maybe I need to add some material, like from when we are doing anaerobic digestion, there is some material to be added, so the biomass itself. So the system will tell you, so the digital will tell the physical what to do, and because everything automated, so automatically it will give the instruction and will act.
Thank you. I think it's time to move to the next speaker, so thanks again.
Thank you.